Okay, everybody. If you don't have any questions from the previous lecture or homework, let's go ahead and get started with the new lesson. So in today's lesson, we're going to continue talking about linear equations. But today, we're going to deal with more than one linear equation at a time. So we're going to introduce what we call systems of linear equations. First, we're going to define what that is. We're going to define linear systems, and we'll see how to check a solution, a given solution. And later, we're going to see how to solve those by graphing. So we're going to have a system of two equations. We're going to see how to solve that system by graphing. So let's first define a system of linear equations. Okay, so far we've dealt with something like this: x plus y equals 3, for instance. X minus y was maybe -2. We dealt with one separately. Each one we took an equation, we graphed it, where we checked whether a pair is a solution, and so on. But today we're going to work with two equations at a time. So this is what makes a system. So a system is made of at least two equations. Okay, that's why it's called a system. These two equations are related, they are linked. So the x's and y's in both equations are related. Okay, so if x and y is a solution here, it should also be a solution in this second equation. So this is what we call a linear system. Okay, so usually there's two equations, so let's call this equation 1. This is equation 2. We're going to check a couple of solutions. Usually when you have a system like this, it's basically these are two lines. These are two lines. And the solution is usually the intersection of the two lines. So you may have, so for example, line 1, line 2. So when you graph these in the same graph, if they meet, then this is the solution. Okay, sometimes you don't meet at all. When you graph them, they are parallel. These are parallel lines, no solution. And the third case is when you draw the first line, then you draw the second one, they end up overlapping. Exactly one on top of the other. Something like this. Basically the same line, okay? You draw the first line, you draw the second one, and they end up like this. So in this case, so we have L1, also have L2 in blue. In this case, many solutions. Okay, what does that mean is, basically when they meet, there's one solution, this point. It's a point here with coordinates x and y. Exactly one solution, the intersection of the two. When the lines are parallel, they never meet. Therefore, they have nothing in common. There's no solution. But when the lines are overlapping, that means one ends up over the other, you have many solutions. Basically, they meet everywhere. All these points along the two lines are solutions. So the lines meet pretty much everywhere. And two lines never end. They extend infinitely in both directions. So here we have infinitely many. You can add that infinitely. Okay, so we have infinitely many solutions. So these are all the possible cases when you solve a system by graphing. You're going to end up with one of these. There's no other case. Okay, so that's what we're going to do today. We're going to see different cases, maybe one of each. So this is one method of solving systems, is by graphing. There are other methods we use to solve systems. We're going to see those later in another day. And those involve algebraic solving without graphing. We have a method called substitution, and another one is called elimination. We can solve these systems without graphing them. So let's start with the graphic or the graphing method one, and we're going to learn the other ones another time. These are usually unreliable because they're not accurate, especially when you have something like this. Sometimes you can't read accurately from a graph. When you draw the two lines, it's hard to get this precisely. But with the algebraic methods that do not involve graphing, we can get the solutions with accuracy if they exist. If the solution exists, we get exact value or values of x and y. Okay, so that's basically what a system is. It's just two or more lines together, they form a system. Number 2, let's see how to check. So checking whether a pair is a solution. To a system. Okay, so before we start graphing, let's try and see what do we mean by xy is a solution to this. So we're going to need a system. So that system will be, let's say, x plus 4y, for example. Okay, so that's a system. So a system may have one solution, may have none or many. Let's choose some random points and see if they actually are solutions to this. So let's try, for example, 0.11. So this is 1 point, x and y. So in order for this to be a solution to the system, it has to be a solution for this equation and this equation at the same time. That's when it's a solution. Otherwise, it will not be a solution. So to check this, all we have to do is take these values and plug them in both of these equations. Okay, I'm going to take xy, plug it here. So this is equation 1. Which is x plus 4y equals -8. What we're going to do is, again, we're going to plug x and y into this equation and see how it works. So x is 1, so we're going to put 1 here, plus 4 times y. Y happens to be 1 as well. And we say, is it equal to -8? Let's simplify. This is 1 plus 4 times 1 is 4, so that's 5. 5 and -8. So that's not a solution. So this one is not a solution to this equation. So we don't even need to check for the other one because it has to be both. It has to work for both to be a solution. But let's try that anyway. Let's try this for the second equation anyway. Even though it will not change the outcome, let's just do it. So if it worked for this one, if it works for the first one, then you try the other one. But usually, if it doesn't work for one, that's it. You don't have to check for the other one. It's already not a solution because it has to be a solution for both. But let's do that anyway. So again, x and y, let's plug them. We're going to plug x and y into the second equation, equation 2.
Sorry, Professor, for being late. I was taking a quiz. I'm so sorry.
That's okay. So 2y plus 6. going to take that second point and we're going to plug it into this equation. So it's going to be 3 times x, which is 1, plus 2 times y, which is also 1. And again, we say, is it equal to 6? This is 3 plus 2, that's 5. And 6, of course, not equal to. So that point is definitely not a solution to this equation, okay? Now let's try another pair. Let's try this time maybe 4 and negative 3. Okay, that's the second pair that we have that we need to check. We're going to take this pair again and we're going to try it in both equations. So this is equation 1, equation 2. These two equations make up a system, and we use a curly brace to link them together to form a system. Now let's plug this into this. So equation 1, so again, the x plus 4y is negative 8. So again, the pair is x and y, so it's going to be x, which is 4, plus 4 times y. Y is negative 3. Again, we need to check. We don't know yet, so we're going to see if this works. We have 4 here, plus 4 times negative 3, that's negative 12. Okay, no need for this plus here. Positive 4 times negative 3 is negative 12. And again, we say, is it equal to negative 8? 4 take away 12 is in fact negative 8. Negative 8. So that's good. So this pair is a solution to the first equation. That's good, but that's not enough. We need to check it. It has to be a solution for this one as well. In order for this to be a solution for the entire system, it has to be a solution here. We checked it works. Now we're going to see if it works for this. If it works for this, then we can say this is a solution to the entire system. So let's do equation 2. Equation 2 again is this one, 3x plus 2y equals 6. So both x and y are here. I'm going to say 3 times x, which is 4, plus 2 times y, which is here, negative 3. And we're going to say, is it equal to 6? So that's 12 plus 1 minus 6 is equal to 6. Yes, it is equal to 6. So that works. So this point works for both this and this. So therefore, this point is a solution to this entire system. It has to work for both, as we saw here. Unlike this one, it didn't work for neither one. So it's not a solution. Even if it worked for one of them, it's still not a solution. It has to work for both. So we can conclude that for the pair negative 3, 4, negative 3 is a solution to the system. The system meaning that system. Okay, so that's how you check whether a pair is a solution or not. Okay, so now we're going to see how to actually solve systems ourselves like this using graphing and see which case of these we're going to get. Okay, so number 3 is solving by graphing. All right, let's take a couple of equations here, maybe y and 3 over 4x probably minus, let's say 2. And another equation, y equals maybe negative 2x plus maybe 4. Okay, so we have a system in 2 equations, as you can see here. And to solve this by graphing, we're going to have to graph both in the same graph. So let's draw a graph. Or it's even better if you use graphing paper. Okay, graphing paper makes this a lot easier and more accurate. So let's do this. Okay, as we saw last time, we want to graph this equation, which happens to be in this form, happens to be in the form of ymx mx plus b. Okay, let's graph this again, which is in ymx plus b. What's the slope of this first equation? Everyone, what is the slope of this equation?
1.
Nope. The slope of this equation, as we talked about last time. So this equation is in this form, ymx plus b. So what is the slope of this equation?
4.
2. Negative 2.
Nope. Again, remember what we talked about last time when we had an equation in this form. What do we call this number m, and what do we call this number b?
The slope is 3 over 4, right?
That's right. This is a slope.
Yes.
And what do we call this? This is the y-intercept.
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 So to graph this, where do you start from on this graph?
3 times x and
No, what do we do first in this graph? So we want to graph this in this graph. So what do you do first?
rise 3 times.
From where?
From 0, from on.
No, you have to start from somewhere. What is that? What's that point that we start from? Just did this 2 days ago. We spent an hour talking about this. This is supposed to be the easiest way to graph. So it's just 2 steps. We start from something and we go somewhere. What do we call this point again? This one?
Y-intercept.
Y-intercept.
Why do we call it y-intercept? Why do we call it y-intercept? Or where would that be on this graph?
Negative 2.
Could be on negative 2. So it's the y-intercept. Okay, so this is
The starting point. We start from I-intercept.
we start from the y-intercept. Well, we start from here on this axis. So negative 2 will be here. And what do you do from there?
Rise 3 times.
Just after that, you do the rise and run. So this is the rise,
Yes.
3. So 1, 2, 3. It's 0.1. And then we go where?
And go right 4 times.
That's right. This is rise and this is run. It's positive, so we go right. If it's negative, you go left. Same thing here. It's positive, you go up. If it's negative, you go down. So we're going to go to the right. So we start from here, go up 3, then to the right 4. So we're going to go all the way here. Okay, so this is 0.4. So you start from here, you go up, and then you go this way. So that's the line. So starting point and the ending point. Then you draw your line through the 2 points. Again, it's better when you use graph and paper and a ruler to get more accurate result. So that's the line representing equation 1. Okay, so let's call this line 1, line 2. Now we're going to repeat the same process. On the same graph, we're going to graph this second line and see how it behaves. It may intersect with the other line, you might not meet at all, or it may overlap. And based on that, we can conclude the solution, if any. So let's do the other one in a different color. So again, where do you start from to graph this second line?
So the slope is -2.
So the slope is -2. This is the rise, and what's the run? What's the run here?
1.
Right, we can say -2 over 1. Rise and
Yeah.
run. The y-intercept, so we're going to start from positive 4.
From 4.
Right, which will be on the positive side of y. This one is always on the y. So we have
Yes.
1, 2, 3, 4. Okay, where do you go from there? So this is our slope. So
2 times down.
that's right, we're going to go down this time because it's negative. So from here, we're going to go down twice, and then?
And then 1 time right.
To the right. So we're going to start from here, go down 1, 2, and then to the right once. Right across from 1. So start from 4, go down twice, then to the right once. So that's the starting point and the ending point. What we have to do now is join the 2 points with a line. So we're going to use another color here. Use the red one. Okay, so carefully draw your line. So something like this. So it's more accurate again when you use graphing paper and a ruler. So how many solutions do you think we have based on this graph? How many solutions? Okay, so we said we either have one, many, or none, or many. So how many do we have here in this example?
One solution.
That's right. There's only one solution, and that solution is the intersection of the two. That's the solution equation for this system. So solution. One solution only because it is only one intersection. Now you just try to read this approximately, okay? I can read it as accurately as possible. You might not get the exact value, but something that's close to it. So what is approximately the x here? You draw this. What is the x of this point? I mean, this is the y. Let's find the x first.
2.
It's close to 2, maybe a little over 2, but let's assume it's
2.
So x is 2, and the y is? This is 2, the y is about? Close
1.
To, so this is 1, this is -1. This is about half, approximately. So about -half. And I said that's the solution of this system by graphing. Again, you may get slightly different result here, but it's all right. If you use graphing paper, it would be more accurate. But again, these methods are not as accurate as the other methods that we're going to learn in the future. So we prefer the algebraic ones when we solve without having to graph, because that gives us accurate results. So that's the whole idea of solving by graphing. When you have a system, graph both lines in the same graph, not separately. And then if they intersect, there's one solution. You read the x and y of that point. If they don't meet at all, not like this, not something like this. Don't do this and think they don't meet. No, if you extend them, these will meet. They have to be like parallel like this. You can see from the graph that they will never meet. This is no solution, but this is, sometimes you have to extend your line to say that before you say they don't meet. Or third case is when you end up with the same line when you graph both. That's fine, just write both of them on the same graph. I graph both of them and then If they end up overlapping, you say no, there are many solutions. Okay, so that's one way. Let's do another one. So another example here. So as we saw the other day, the equations are not always in this form of y mx plus b. This is the slope-intercept form. Okay, but we also have the equation can be in this form of sometimes it's ax plus by equals c. This is slope-intercept. And this is the standard form. So this one is easier to graph, as you saw, start from here, rise and run. But if the equation is in this form, then we have to do a little table, find some points before we can graph the line. Let's do an example of that. So again, let's use maybe 2x plus 4y. Let's see, actually, maybe use something else. Okay, we can use that one, no problem. So I have 2x, 4y, for example, 8. And maybe x minus 2y equals 4. So as you can see here, we have these lines in standard form. So we can't use rise and run unless it's like this. Rise and run or the slope-intercept form, usually the y is by itself and the rest is here. But with these, you see we have x and y in both directions, in both on both sides. So we have the standard form. So to graph this, as we saw before, we need a little table, x and y. Then we saw this about a couple of classes ago. Then you put 0 here, and you find these values. You find this x, this y, and this x. This is what we called the x-intercept. And this point here is called the y-intercept. So the x-intercept is when the y is 0. The y-intercept is when the x is 0. Now we just need to find the missing numbers here. After you do that, we can graph these 2 points. This is one point, this is another one. Once we complete them, we can graph them and then draw a line through them. We're going to do this for both lines. Okay, we're going to do this table for each line. So line 1, this is line 2. Again, we talked about this in detail about 2 classes ago. You may want to review that video. So let's do line 1 first. And after that, we're going to do another table for line 2. Same way, each line needs to have its own table. So x, y. And again, start each one. So this one was 0, this one was 0. We're going to find these missing values. So there's separate lines here. So how do you find, so now we're just doing line 1. You have 2x minus 4y, which was 8. So for this first point, we have y, which is 0. So we're going to plug it here and find x, which is needed here. So it's going to be 2x minus 4 times this y. Okay, because we know y, so this cancels out. So we have 2x equals 8. That means x is 4. So this is our first missing value here, 4. Now we're going to do the same thing for the other one. So now this time we have x, but we don't know y. So we're going to take the x. Again, we're still working with the same equation, the first one here. So this time we're going to put the x here and then find the y. So it'll be 2 times x, which is here, 0, minus 4 y. So y we don't know, and we're looking for y. Okay, we need y here, so we're going to plug the x. We did, minus 4y equals 8. Again, this first table is all about this first line. Once we're done with the first line here, I'm going to repeat this exact same thing with line 2 over here. So this cancels, negative 4y equals 8. If you divide by negative 4, divide by negative 4, y will be negative 2. That's our second missing value. So that's good. Now we have enough points to graph the first line. Okay, so we're done with the first line. Let's grab it now, grab that line, and later we will do the same thing for the other one. So let's use a graph somewhere here. Oh, let's put that graph over here. So this is the x-axis. Of course, this will be the y-axis. Okay, so for the first line, we have 4, 0. Where do you start? Where do you go to plot this point? 4, 0. How do you put that? Put this point on this graph?
x4.
Okay, you start from x4, which is approximately here, and
And it's a point.
then we stay here because the y is 0.
Yes.
Usually if the y is positive, we go up, down. If it's negative, we go down, but it's 0, so we stay right here. So that's our first point of this line, 4, 0. So this is 4, 0. Then we want to graph 0, 2. Where do you start and where do you go to graph this point?
2 on y will go up,
We start from the x, which is 0.
which is 0.
And where do you go from there?
2 times up.
That's right. Start from here, 0, go up twice. That's going to be 1, 2. And that's it. That's our first line. And carefully draw that line. Again, it's better to use graphing paper. Okay, so all of this just to graph line 1. But again, that's a system, so we have to do both. So we're going to repeat what we have done now. We're going to repeat the same thing with line 2 and then grab it here on the same graph with line 1. And then we'll see if the lines meet, not meet, or overlap. So let's repeat the process here. Okay, so the equation here is x minus 2y. Okay, is 4. So we're going to plug this time 0 in the y. So we're going to plug it here. So it'll be x minus 2 times 0 equals 4. So that cancels out. That means x is 4. So that's our first missing point. Then we're going to do the same thing. This time we know x, so we're going to put the x here, and we're going to find the y. We don't know the y yet. We're going to find it. So it'll be 0 minus 2y equals, it means negative 2y equals 4. If you divide by 2, or negative 2, we're going to find that the y is negative 2. So that's the number we're looking for here. Y is negative 2. Okay, so what is left to do now? There was a little mistake, but nobody paid attention to it. You look back here, the y is -2. The y here, for this y, should be -2. Instead of 2 that I put here, should be -2. So this line will change a little bit. So where would this point be now? 0, -2 will be, start from 0, go down to -2, which is here. Okay, so this is the first line. So instead of, because it's a negative here, we didn't put the negative here, so it has to be. So it's something like this. So that's line 1. Now we have line 2. So line 2, we finished the table. If you notice, that's actually the same thing. That's the same line. So if you grab 4, 0, so it's going to be here. 4, 0 will be here. And also 0, -2 is the same as this one, 0, -2. So 0, -2 again will be here. So basically, line 2 will also be the same as this line. As you can see, the lines, let me actually use, some lines here. So the first one, the green line, and also the blue line. Both of these lines, or the red line actually, blue and red, okay, the green. So what do you think of these two lines? How many solutions do you think we have?
Many solutions.
That's right. So this is many solutions. As you can see, both lines overlap. So that's not a problem if you end up with something like that. It just means the two lines overlap. So we have many solutions. Basically, these two lines, the blue and the green, they meet everywhere. On every point, they meet. And again, these lines extend infinitely in both directions. So extend infinitely in both directions. So we have so many points. All these points, a line basically is an infinite number of points. So we have many solutions. Okay, overlapping lines. And that's pretty much how you solve linear equations with by graphing. So linear equation by graphing, when you you graph both lines on the same graph, then you see how they behave. So far we had this case, we had that case. So again, if the lines are in this form y mx plus b, so you use the method of rise and run and y-intercept. If it's in standard form, you want to do this, x and y intercepts. Again, we talked about each one of these in detail in the previous lectures, so you do want to review that so for this to make more sense. Okay, everyone, do you guys have any questions this moment, this point, before we move to example? Everybody else, are you guys on board? You guys awake?
No questions.
Everybody else, you guys here?
Yes, we're here.
Okay. You guys all right? Any questions? Do you understand what we're talking about here?
I'm gonna go over the video, to be honest.
Okay, you can also I mean, you came in a little late. You can rewatch the thing. But again, you can always ask questions. Please let me know in a moment. Okay, let's do one more example. Same way, so same process. So again, this is related to what we've done before. So we've talked about graphing this form and this form before. So you do want to know or review that for this to make more sense. So let's go to number 4 or number 3, but actually just another example. Okay, again, the idea is we have a system like this. So let's say y is 2x minus 3, for example. Another one maybe 2y plus 4. So we want to solve this system by graphing. So the idea is we're going to put both of these in a graph like this. So we're going to put both of these lines on a graph, x and y. Once we graph both of them here, we're pretty much done. We're going to look at whether they meet, not, or the overlap. If they meet one solution, we read that from the graph. If they don't meet, no solution at all. And if they overlap, we have many solutions, as we just saw here with this example. So again, in what form are these lines? Is it the YMX form or the standard form? What form is that? From these two forms we talked about earlier. Is it the slope-intercept form or the standard form?
Slope-intercept.
That's right. How do we graph those? Do we need to do this? Do we need to use these tables?
No, we don't. We don't.
No, just gonna do like we did here. The intercept, the rise and run. Okay, so let's do the first one. So where do you start? Where do you go to graph the first line? So this is line 1, line 2. Let's graph that.
First, we start from -3.
That's right.
Drawing it on the Y line.
That's right. That's -3. The y-intercept. This is the y, the intercept, and then yeah.
Then we're gonna up 2 times and run 1 time.
Exactly. So this is the slope. If you don't have the run, you can add 1, but 2 over 1. So you can start from here, go up 2, 1, 2, and then to the right once, right over here. That's it. That's the first line. Let's graph that first line with a color like this one. Let's try again. Okay, so that's pretty good. That's line 1. Okay, that's this line. Let's do the same thing again with this one. What do you do? Where do you start from? Where do you go? This time I'm going to start
from 4.
Right, positive 4 on the y. So the y-intercept always start from here. So it's going to be 1, 2, 3, 4. So that's the first point. From here, again, we need to do rise and run, which happens to be the same thing, 2 over 1. So we're going to start from 2. Start from here. Where are we going to go from here?
2 times.
That's right, we're going to go up 2, and then once to the right. So
once to the right.
Going to go up 2. Start from here, then about 2 units. From here, 1, 2. We end on 6, and then to the right again once. H is around here. There's 1, this is 1, so we're going to go, we went 1 once to the right. And that's our second line. Let's grab a line to draw it. So we're going to do again the same thing. All right, so what do you guys think about these 2 lines? What do you think about these two lines? This is line 2. Or in other words, how many solutions do we have?
It seems that no solution
Okay, why not?
because they are not made and will not meet never.
Exactly, because lines are parallel. So these lines, just like here, they will never meet. Therefore, they have nothing in common, no solution. And that's all you have to do, say no solution. And that's pretty much how we graph linear equations. We saw all the different cases. So just graph your lines first in the same graph. If they meet, that's your solution, your unique solution. Read the points. If they end up overlapping, that's fine. You just say many solutions. All these, basically everywhere they meet is a solution. In this case here, there's no solution. So that's pretty much how you graph systems by, how you solve systems by graphing. So again, we've started talking about linear equations 2 classes ago. We talked about standard form on y-x-intercepts on the first class. So you should know how to graph your lines using a table. Then previously, the past class, or the previous class, we talked about the y-mx form, how to graph using y-intercept, rise and run. So I recommend you review those videos first if you forgot how to do that. Even though we kind of did it today, reviewed it, but still rewatch those videos because this is based on that, like 80% of it or 90% is based on that. The only thing that we added today is a system or a second equations, and we work with 2 equations at the same time. Okay, you guys all right so far, everybody?
Yes, Professor.
Okay, everybody else, you guys on board? Didn't hear from a couple of you.
Okay.
Solving the system, we did that.